This is Group 5's Cragside Project Documentary. Models can often be combined with simulations to aid the calculations of things such as wind loads and thermal transfer throughout a structure. These models and simulations can help architects to visually present their ideas to clients, quantity surveyors to estimate costs, and project managers to come up with plans and project budgets. In other words, BIM promotes collaboration between AEC professionals, allowing them to work together in the most efficient manner. The aim of this presentation is to allow you to gain further understanding of some of the key aspects of BIM. These are as follows: prevailing protocols and standard approaches to collaborative working within the integrated AEC practices, the role of advanced project monitoring tools in expediting error detection, prevention and quality assurance in AEC projects, advanced decision support and project information management tools in the AEC practices, potentials and barriers of adopting digital engineering, BIM and integrated project delivery within the AEC domain.
Prevailing protocols and standard approaches to collaborative working within the integrated architectural, engineering and construction practices. Now, the standard approach is to use the BIM model, and the BIM model is all about sharing information, and how this progresses is we're moving from the older model into the newer model, and the diagram in front on the page shows progressing from level 0, which was a very linear process where one person produced the information or the paperwork, passed it on to another, and anything that needed to be changed went straight back to the beginning of the cycle to be changed. And as we move further and further along through the levels, this sharing of information becomes much more slick, much less linear, and simultaneously people are able to add, innovate and design with each other in conjunction with the other technicalities. So the workflow of this BIM, this approach, involves extensive client communication, and this is important as gaining the information that's needed from the client is imperative in producing the output that they want. Making sure everyone is on the same page at the same time, working towards the same goal simultaneously. And this is all about efficiency and economy of effort. And finally, inputting individual resources, multiple different resources of information, different ways of designing, all into one format that everyone can work on at the same time, progressing together. Why is this approach beneficial? And this all boils down to cost and time efficiency. All these points come down to cost and time efficiency. Being consistent saves time. Having multiple disciplines working at the same time as opposed to in a linear fashion saves time. Working, as I said, at the same time in a set organised order saves time, and the time is money. Everyone sharing their expertise and innovating together will enable not only this project to be more cost and time efficient, but also to produce a better outcome, and leading to the seriousness of these projects, i.e. what is at stake when they don't go right. That is crucial. So the challenges this approach brings is when visualizing through CAD and other softwares, we can come across certain discrepancies and certain misunderstandings. And the way BIM overcomes this is by everyone working together at the same time enables better communication, whereas previously there'd be stagnant periods where people were disagreeing on designs, and it would all have to go back to the beginning stage, back to the drawing board, as it were. Different legislations can relate to different aspects of the project, and this previously has been a huge problem and could be potentially a problem now. Again, BIM negates this, or at least tackles this in a different way by enabling greater simultaneous work and collaboration to understand and overcome this issue. And finally, the biggest challenge, arguably, with the AEC industry is being able to input so many different disciplines all at once. And this approach enables that controlled thread of information to be organised and efficiently taken in and then input into the model.
Role of advanced project monitoring tools in expediting error detection and prevention and quality assurance in AEC projects. The roles of the various advanced project monitoring tools are extremely vital, as when in use can easily detect identification of errors at an earlier stage of a structure lifestyle or project program plan. For example, in our case, the Craigside Boathouse construction. Regarding the detection of errors, it should be during the pre-construction stage on a construction program early on. This helps in efficiency and smooth running of the project when in actual construction, saving time, money and resources and materials, and further helps the client, as unnecessary money, time and material issues aren't a problem, hence saving costs that can perhaps be spent in other parts of the project of higher importance. Linked to the first point, there can be a lower chance of injuries and accidents occurring during the actual construction. Without the tools, it can be a serious risk, even with the smallest of errors. Advanced project monitoring tools can prove to be beneficial and aid throughout the project with regards to collecting data and important points. The data collected can be used later in the project, and when in need can prove beneficial to the required needs. It can also be amended upon later updates and changes, hence again saving time, costs and resources. Linking to the Craigside project, data collected at the pre-construction stage, for example, is constant, but can be updated upon review or any change accordingly during a later stage in the project, and thus is helpful. Challenges do occur and are mainly to do with the inaccurate and imprecise site layout dimensions drawn on the software used, such as BIM or any CAD softwares. This is usually a human error visually on the software. Improving accuracy and precision can help in preventing errors. Revisiting the data, spotting any inconsistencies, and regular visual checkups on these tools/softwares allow errors to be spotted and hence corrected before the construction phase stage later on.
Advanced decision support and project information management tools in AEC practices. So, why is it important? Project information management and support tools have a vital role in the different phases of a project, from inception to completion. For example, in the Craigside Sailing School project, these tools were implemented to help project managers make better informed decisions about scheduling resources. What tools are used? GIS BIM. Various individuals can view the design from various stages of the construction life, including past, present and future plans in the form of GIS generated maps. Augmented reality. This greatly improves information management and the decision process within a project. It does this by overlaying information such as notes, images and audio commentaries to individual designs and the overall BIM model. Record modelling. This allows accumulated information such as the configuration and assembly of components of construction using precise dimensions. This technique is useful for the construction teams to prepare detailed specifications to be handed over to the maintenance teams in the occupancy phase. Photogrammetry. This allows measurements to be taken from photographs taken on site, which then can be contributed to the updated detailed BIM model. This is especially useful for the project management in identifying issues with construction and the best ways to proceed in the project. Some of the drawbacks of implementing these tools include training. Training is needed to use these tools efficiently. Many companies can be reluctant to allocate the time and resources needed for adopting these BIM tools. The purchasing and licensing of these tools can be very costly to the practice, and the practice should be a substantial long-term investment for the company. Liability and insurance risks. Traditionally, contractors rely on drawings provided by the designer, and so will have no significant involvement in the design. So they can see designers for professional negligence if errors are found in the drawings. However, BIM allows the contractor to actively get involved in the design process. This means accountability for errors and negligence for insurance and claims can be hard to determine.
The potentials and barriers of adopting digital engineering, BIM and integrated project delivery within an AEC domain. So, as already mentioned, the main potential of BIM is that it helps to quickly transfer information between different individuals. So that can include your designers, contractors, clients. This can allow for a greater increase in complexity to the build. It also helps to reduce costs, mainly by eliminating delays and increasing the efficiency. Also means that you can help improve your resource management, which can help increase your sustainability and also help to decide on more sustainable materials. So some of the pre-construction potentials is that, again, it's eliminating delays, but also helps to eliminate your conflicts between your different professions. You can also use clash detection tools to help identify issues earlier on, which again saves you money in the long run. You can determine if the proposed building meets your requirements earlier on in the construction process. Also, you can use tools that help you visualise the structure, which can help to speed up many different aspects of the build, mainly in decision making. You can also have a much better cost estimation as you have a model-based system, which helps to get a more accurate representation of the costs. Some of the during construction potentials are that any changes can be made quickly, and it very efficiently shows any knock-on effects. It can lead to safer construction sites by highlighting potential hazards in the pre-construction phase and making sure that the appropriate actions are there in place to avoid any risks. It also helps to improve the scheduling, which can again save time and money. And it also means that should any changes occur in the project, documentation can easily be changed. Some of the post-construction benefits are that it's more enhanced for commissioning and handover. It means it makes it easier for both the client and the contractor to get the correct information handed over. This also means that the client can have the relevant information for maintenance, for such as safety systems. And it also means that the building model can be used by the client to show how to operate the building effectively. However, there are some drawbacks to BIM. So one of the main drawbacks currently where we are is that some of the tools do not work well together at this stage, which means you need very skilled personnel to combine projects together, and then this can also lead to errors. But as more companies integrate BIM, this should become less of an issue.
As previously mentioned as well, there are some legal issues with BIM, mainly in the ownership and responsibility. Because with everyone working on the model, it's sometimes unclear who is responsible for which part, so should anything go wrong, there can be some legal issues in that respect. Another issue is the implementation of BIM, in the fact it will take a lot of time and money, as many different parts of businesses will have to change in order to facilitate it.
In conclusion, it's clear to see that BIM is a useful tool that can increase the efficiency of a project. Implementation can be in a variety of ways depending on the needs of a project. It enables vital collaboration through various stages from the initial design all the way to the finished product. Complex technical information can be presented to clients and contractors and easily explained through aesthetic visual models. The usefulness of BIM is likely to advance as technology progresses in the future.